away from my normal health side, and I decided that I was going to look at a sample of, not a sample, but a drawing basket of 5 M&Ms, one of each color. These are the original M&M colors. And then look at how many primary colors I could draw if I was only drawing 3 M&Ms out of those 5. So these are the different combinations, and all I did to get these is I just went red, brown, yellow, red, brown, orange, red, brown, green, and then so on and so forth. And so the total number of draws that I got was 20, and down here, this column right here, you can see where I got, okay, so there's 2, red and yellow, 1, red, 1, red, 2, red and blue, and so on and so forth. So what I went ahead and did after that is I came over here and I made a column of number of primary colors. And I don't know why it says K1 plus L5 there. Okay, anyways. So then my number of primary colors were 0, 1, 2, or 3. You can't have 4 and you can't have -1, obviously. And then the probability was, well, this occurred 1 time. So 1 divided by this total number of draws down here is 0.05. And this occurred 9 times, this occurred 9 times, and this occurred 1 time. So 9 divided by 20 is 0.45, 0.45, and then 0.05 again. And all I did to create this graph was I went like this and went to insert and recommended charts and did this chart right here, and then just removed the space in between. So this is my histogram for that, which you can see is a nice normal curve, and I was pretty happy with that. Although it does make me wonder if maybe I did I might not have come up with all the combinations, but these are the ones that we're going to pretend that I have. So over on the y-axis is the probability, and then down here is just the number of primary colors. Okay, so that was from random sampling. And over here, we got much more complicated. So I made my columns again with the different colors, and I went ahead and formatted all down to 31 because we wanted 30 draws. So I formatted these as bold and underline, these as bold and underline, and then these as bold and underline, so that when I went through and did this, I could tell easily which ones were primary colors. So I'm just going to show you down here what I did. So I did equals 1,000 times rand, and then just do this and hit enter. And then I went ahead and got rid of the decimal points because I don't want them. I drug that over, and then I went to conditional formatting because I want to choose 3, right? So I did top bottom rules, top 10, except for we don't want top 10, I only want 3, and it will choose the 3 highest numbers and then highlights them with red ink, dark red ink, and then a dark red cell background. So that was how I did that, and then in order to keep that, you just click paste and it will keep that formatting. So I went ahead and did that for all 30 of my draws, and then I went and made this column here, this number of primary colors, and went through each one of these, and you can see it's pretty easy with this bold and underline to be able to tell how many there were. So after I did that, I put my total number of draws, and then you come over here and I have the same kind of chart as the last time. So I have number of primary colors, number of occurrences, and then the probability. And in order to make this graph, I did the same thing except for you had to select your data. So I made a recommended chart. I went like this, made a recommended chart, and then just changed the Y data to these numbers over here. And I didn't point this out before, but those numbers also added up to 1, which means that we're good. Probability is correct. So on this one, you can see that my probability looks much different, which made me think that maybe I did the other one not quite as accurately as I should have, but hopefully someone can verify that for me. And then what I wanted to do is I wanted to look at the minimum, which is obviously 0, max is 3, and then look at the expected value of x. So this is actually the average of x. What we would expect it to be is about 1.63. And I watched the professor's video on how to do this, so don't mind me if I'm trying to figure out where this triangle is. So I'm just going to insert a triangle, and we're going to put it about, so I would say like right here is 1.5, so we'll put it like right here. Looks good to me. And then I'm just going to move it so that it's about where I want it to be. Okay, that looks good. And then the standard deviation of x is 0.67. So if we want to look at where one standard deviation would be, because we know that's where most of our data is going to be, we can go right here and say that that is about that right there is about where we could expect one standard deviation to fall. So then I'm going to take another one and insert it back on the other side. There we go. So I'm going to bring this up a little bit higher just so that you can see it easier. But with this, we can kind of see that this is where most of our data falls, which obviously by the arrows there, we can tell that that's true. So that is my presentation, and thank you guys for watching.